Okay, so here's question number 1 from section 2.4. They're giving me a triangle. So this is application. So we're going to get into, something you can actually do with all this trig stuff. We've been learning a bunch of theory up to now. We're just going to begin. We'll do more in future sections to apply things, but we're going to take one break here at the end of this chapter from developing more and more theory and say, okay, what do you do with this stuff? Well, here's something. This doesn't probably seem super practical to your life either, but there are things in real life with engineers and scientists where they find sides of triangles and things. So let's solve this triangle using the trigonometry that we have learned up to this point. So first off, let me tell you about this general triangle. They're always going to give you the same general triangle. So it's helpful if you kind of get used to it. What do I mean the same general triangle? They'll say the 3 points, they'll do with capital letters. See how they have capital A, B, C like that? And then notice that the same letter is across from the side. So across from the angle. Across from angle C is side C, little c. Across from angle A is side A, and across from angle B is side B. That's no coincidence. They'll always do it that way. That way you know what they're meaning whenever they say something. So the A goes with the A across, B is across from B, C is across from C. Why? Because they're putting into, there's also a mechanical reason, because they're putting into your mind that an angle, how big an angle opens up, affects the side across from it, right? Angle A, how big angle A is, affects how big this side is. If angle A was a bigger angle, well, that looks kind of goofy. Let me try it again this way. So if instead of opening like this and being that side, if instead angle A was way up here, if angle A was bigger, angle A here, if angle A here was bigger, it would make side A bigger, wouldn't it? The size of this angle affects the size of the side across from it. So they're just putting that idea in your mind. Angles affect the sides across from it. We're going to play heavy on that and get a law of sines later in the course where we use exactly that to do something more fancy with triangles. But for now, angles affect the sides across from them. So that's why they set up the A across from A, the B across from B, the C across from C. Okay, so now what they're giving me, 38.7. Boy, I messed this all. Let me clean this up here. And they're telling me that this is 38.7 degrees. Little b down here, this side, is 47. And they want me to find everything else, basically. They call it solve the triangle, which means find every side and every angle. So can you find like everything about that triangle from just knowing one side and one angle? Yes, if it's a right triangle, and this one is. Notice we have a right triangle. Later in the course, we'll learn how to do this with triangles that are not right triangles, don't have a 90-degree angle. But for now, right triangle. Okay, yeah, so with a right triangle, yes, you can. First off, you could do a lot of things, but why don't we, I think the easiest thing, why don't we first find the other angle? This angle up here. How do we find that other angle? Yeah, do you know, subtract what? Yeah, exactly, yeah. Because do you know that every triangle holds 180? And this one's already using up 90 here, so the other two must get to total 90, so subtract from 90. You track with all that again. Every triangle holds 180. Every triangle, right triangle or not. Every triangle holds 180 degrees. Let me write that down. Every triangle is 180 degrees for his 3 angles, no matter what the shape is, every triangle. So, and since we have a right angle, which is already using 90, that means the other two just have 90 left. So you can find angle B by taking 90 minus 38.7. What is that? 51.3. So angle B, so we got angle B. Let me write that in. It is 51.3. Okay, so we got all the angles. Now we just need the other two sides. We have one side and all the angles, because we know the other one's 90. So now let's find the other two sides. Let's start with little a. It doesn't matter. We'll do whatever one you want. How about little a? So how am I going to find little a? What could I do to find little a? Well, really, I could do a lot of things. How about I just use this original angle that they gave me and the original side that they gave me? I'll just use those two. So what trig relationship do you know? Think about SOHCAHTOA. SOHCAHTOA is true in a right triangle. Only in right triangles, but that's what we're dealing with here. SOHCAHTOA. So what little a is what? Opposite side. This is the adjacent side, and this is the hypotenuse, isn't it? From the 38.7 perspective, right? So from the 38.7, the little a is opposite. So what trig relationship involves the little a and the 47, the b? Opposite, adjacent, TOA, tangent. So tangent of 38.7 degrees is going to be little a, which I don't know yet, over b, right? It's opposite over adjacent, isn't it? It's little a over 47. So I can use that to solve for little a. So that trig relationship's allowing me to solve for little a there. How so? How do you solve when you have like a fraction and something that's not a fraction? Put it over 1, cross multiply. I don't know if we've done that in here or not. I can't remember. But yeah, just put this over 1 and go diagonal. Diagonal is about the easiest thing to do. So then that'll be 47 tangent 38.7 degrees is 1 times little a. You tracking with that? And so that's it. 1 times little a, that's a. And then the other side, figure it out in your calculator. They want a decimal on your calculator. But you got to make sure you're in degree mode now. Earlier we went into radian mode, but this one clearly has got a degree symbol, right? So it's degrees. So you got to make sure you're in degrees there. So take 47. So I got to shift my mode. Is that what they say, 10th? Okay. Thank you. So 47 tangent. Oops, I did it twice. 47 tangent. 38.7. I'm getting 37.65. I'm going to round it in a second. 37.65. They want me to round that to the nearest tenth. That'd be the first place. So you know how rounding works. You circle the place you're going to round, the place you're going to end at. Look 1 to the right. If it's 5 or more, you go up, huh? So 37.7. So little a is 37.7. Come over here and go 37.7 for little a. Like that. Good so far. And now we need to get little c. So I want to say a word about getting little c. Is everybody caught up here? I don't want you to be doing something else and not catch this, because this will save you a lot of, you could have some frustrating hours of your life wasted if you don't catch what I'm about to say. You might, it would be natural, it'd be totally natural, and in many ways makes a lot of sense to say, well, I'm going to find, all we got left is c, right? Let's see, it's think, well, I'll just do the Pythagorean. Just a squared plus b squared is c squared. That's true, mathematically, absolutely true. The only problem with it, why it'll probably not give you the right answer, is because this is a rounded number. It's not exactly 37.7, right? My calculator said it was 37.65410032. You know, there's more to it. So you don't want to use a rounded number. That's the message I'm trying to say. You don't want to use a rounded number because it'll throw off the other things. And you'll be doing everything right, but the final answer will come out wrong because you used a rounded number, which wasn't exactly right. Now, you could, if you're thinking, well, I just really want to do it, you could. You're just going to have to do more accuracy. So let me say it that way. If you want to use a rounded number, it's okay. Just put about 2 or 3 more places on it than you need in the end. And that'll make it right in the end. Does that make sense? If this whole problem is about rounding to the 10th place, fine, great. Well, then if you're going to use a rounded number like the 37.7, you better use about 2 or 3 more places. Then it'll be okay. Then it'll make your final answer accurate. Does that make sense? So if you're ever going to use a rounded number, use more places than you need in the end. Or just don't use a rounded number. So I'm just going to do it without using the round. I'm just going to use numbers that are not rounded, is what I usually do. So I'm just going to say, I'm going to go back to the 38.7. I need the C, and I'm not going to use and I'll use the B again. So how can I use the 38.7 angle, the B again, since that's not rounded, and I need to find the C. So what trig relationship involves the 38.7 angle, the B, and the C?
Cosine.
That's adjacent and hypotenuse. Cosine. Remember SOHCAHTOA? That's adjacent and hypotenuse. So that'll be cosine. So I can just do it that way. I'm not using rounded numbers. I know everything will be right on the money. Make sense? Otherwise, you'll get answers that are barely off, and math excel's hassling you, telling you no, 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 and you know you did everything right, and you're wondering what's going on, and hours of your life spin by. So you don't want to do that. You have a limited number of hours, so do I. So, all right. So let's come on up here, and I hope that's okay that I'm erasing all that. And then we'll do the, so cosine. So cosine 38.7 degrees is going to be adjacent over hypotenuse, so that'd be the 47 over the hypotenuse C, right? Adjacent over hypotenuse there. All right, so we need to solve that. How do we solve fraction, whole number, put it over 1, and diagonal, diagonal, cross multiply. So I get C times the cosine of 38.7 is 1 times 47. Good to there so far. And then C's not quite alone yet. It's times right there. What do you do to get that C completely alone? Divide, right? Yeah, so in the end we have to divide by cosine 38.7 degrees. Cosine 38.7 degrees. Hit the buttons on your calculator. And I'm getting 60.2 rounded to one place for C. We solved the whole triangle. Found all the angles and all the sides using our trig. Make sense? Questions on that one?